Welcome to the Platform Engineering Playbook podcast, where everything you hear is built, reviewed, and improved by AI, by me, and by you, the listener. This show keeps me, and hopefully you, up to speed on the latest in platform engineering, SRE, DevOps, and production engineering. It's a living experiment in how AI can help us track, explain, and discuss the fast-moving world of infrastructure. Every episode is open source. If you've got something to add, correct, or challenge, head to platform-engineering-playbook.com. You'll find all the content and a link to the GitHub repo. Open a pull request, join the conversation, and make the playbook smarter. Let's get into it.
Today we're diving into site reliability engineering principles and a stat that's been bugging me. Only 26% of organizations actively use SLOs in production. After more than a decade of Google's SRE book being treated as gospel, why are 3/4 of companies still not implementing the core practice?
That's the reverence reality gap. Everyone talks about error budgets and SLOs at conferences, puts SRE in job titles, but actual implementation? Way lower than you'd expect.
Exactly. And meanwhile, 49% of those same organizations say SLOs are more relevant now than last year. So it's not that people think it's irrelevant, they just can't make it work.
Right. And we've got this whole platform engineering movement creating confusion about where SRE even fits. Platform engineers averaging $115,000, SREs at $127,000, and teams asking, do we need both?
Yeah, and then you add AI and ML systems, multi-cloud chaos, and suddenly the playbook from 2016 feels incomplete. Are the principles wrong, or is implementation just broken for 2025's complexity?
That's what we need to figure out, because there's real wisdom in Google's SRE principles, embracing risk, error budgets, blameless postmortems, but the world got more complex than the original model assumed.
Okay, let's start with what Google got right. What are the timeless principles that still work universally?
Error budgets are brilliant. They transform reliability from political arguments into data-driven decisions. If your target is 99.9% availability, you have a 0.1% error budget. That's 1,000 failures per million requests over 4 weeks.
So instead of arguing whether we should deploy on Friday, you look at the error budget.
Exactly. When you have budget remaining, release fast. When it's depleted, focus on stability. Google says it beautifully in their SRE book. Extreme reliability comes at a cost. Maximizing stability limits how fast new features can be developed.
And users can't even tell the difference between 99.999% and 99.999%.
Right. So why spend engineering effort on that last 9? Google's approach is to treat the availability target as both a minimum and a maximum. Don't over-engineer.
Okay, but here's a concrete example. If I have a 99.999% quarterly SLO and a problem consumes 0.0002% of my queries, how much of my quarterly budget did I just spend?
20%. That tiny problem just burned 1/5 of your quarterly error budget. And if a single incident consumes over 20% of your quarterly budget, Google's policy requires a postmortem with highest priority remediation actions.
So the math is elegant, the philosophy makes sense. Why is adoption only 26%?
Because implementation reality is brutal. First, technical challenges. Observability data is siloed across Splunk, Prometheus, service mesh platforms. Teams need architecture maps just to know which vendor each service uses.
And manually tracking error budgets is
Impossible at scale. You need automation. But here's the kicker. 85% of organizations adopted OpenTelemetry. The tools exist. Only 26% are actually using SLOs. So it's not a tooling problem, it's a process problem.
What about organizational challenges?
Culture transformation is harder than anyone admits. Successfully implementing SLOs requires real commitment to culture and process transformation, which is often harder than anticipated. And the biggest challenge? Setting unrealistic targets,
Like promising 99.99% uptime.
which allows 52 minutes of downtime per year. Most teams promise that without understanding the math. Then they blow through it in the first month, and the SLO becomes ignored.
So teams set targets they can't meet, which undermines the whole system.
Right. And error budgets only work when product managers, developers, and SREs all understand and buy into the system. That cross-functional alignment is rare in practice. One team told me their product managers thought error budget is something the SRE team tracks.
Ouch. But wait, isn't this stuff supposed to be mature by now? What changed?
3 big shifts since the original SRE book. First, AI and ML systems break traditional SRE assumptions. You need data freshness SLOs. How recently did the model get data for inference? Stale data equals bad inferences.
And downtime costs are different.
Catastrophically different. LLM training takes weeks. One downtime incident might burn tens of thousands of dollars in compute. Traditional error budgets don't map to that economic reality.
What about platform engineering? Everyone's talking about it, but how does it relate to SRE?
Platform engineering focuses on developer velocity and experience. SREs focus on maximum reliability. The way I think about it, platform engineers build systems that SREs operate. Collaboration is key, but roles are getting confused.
Glassdoor shows platform engineers at 115,000, SREs at 127,000. Partly because SREs are handling 2 a.m. incidents.
Exactly. Platform engineering life is more predictable. But here's the thing, they're complementary, not competitive. Platform teams can use SRE principles to build more reliable platforms. SRE teams can use platform engineering tools to improve reliability.
Hold on, even Google is evolving their approach?
Yeah, this surprised me. Traditional SRE methods, SLOs, error budgets, postmortems, progressive rollouts, hit a limit with highly complex systems. Google SRE is now adopting STAMP, which stands for Systems Theoretic Accident Model and Processes. They're bringing in systems theory and control theory for a new approach to reliability.
So if even the originators are saying the original model has limits, what does that mean for the rest of us?
It means the principles are timeless, but implementation must evolve. Let's talk about what to keep versus what to adapt for 2025.
What works universally, regardless of complexity?
4 things. Error budget philosophy, aligning product and reliability incentives through data, embracing risk. Availability is both minimum and maximum to avoid over-engineering. Blameless postmortems. The 2024 CrowdStrike incident reinforced how critical this is. And toil reduction, keeping repetitive work below 50% of engineer time.
Those don't change.
Right, but how you implement them must adapt. You can't do SLO instrumentation manually anymore. You need OpenTelemetry plus automated SLI calculation plus incident integration. Spreadsheets don't scale.
What about ML systems specifically?
Add ML-specific SLOs. Model freshness, prediction latency, training pipeline success rate. And your error budget math needs to factor in training costs. One failure might burn tens of thousands in compute, so the cost per incident is different.
And platform engineering teams.
Adopt SRE principles for your platform. Your platform is a product. It needs SLOs. Deployment success rate, time to environment, self-service completion rate. Then provide SLO infrastructure for app teams. Build the observability and error budget dashboards they need.
Okay, here's my controversial take. Maybe 26% adoption isn't a failure. Maybe not every organization needs formal SLOs.
I've been thinking about that. You're right that not everyone needs the full SRE apparatus, but everyone needs error budget thinking. Understanding we have capacity for X failures this month, how do we spend that budget? Even without formal SLOs, that mindset helps.
So let's get practical. What if I'm starting from zero?
Pick 3 to 5 critical services. Not everything. Your top revenue generators or highest impact platforms. Define 1 SLO per service initially. Availability or latency. Not both. 99.9% is reasonable. That's 43 minutes of downtime per month.
Automate from day one?
Absolutely. OpenTelemetry to automated SLI collection to error budget dashboard. No spreadsheets. Get cross-functional buy-in. Your product manager must understand the "we have 400 failures left this month" decision framework and target a 12-month timeline. From zero to making release decisions based on error budget takes a year. not a quarter.
What if SLOs exist, but everyone ignores them?
Audit why. Ask teams. Too complex, wrong metrics, no enforcement, no tooling, then simplify radically. Cut to 3 SLOs maximum per service, each tied to actual user pain. Enforce once. Next error budget breach, actually freeze releases. Demonstrate it's real.
And automated reporting?
Weekly error budget burn emails to product and engineering leadership. Make the data visible.
What about platform engineering teams listening to this?
3 things. First, adopt SRE principles for your platform. Deployment success rate, environment provision time, self-service completion rate. Second, provide SLO infrastructure for app teams. Build dashboards and error budget tracking for app teams. Third, collaborate with SRE. You're complementary, not competitive.
And if I have AI or ML systems?
Read Reliable Machine Learning from Google's SRE team. It's specifically about applying SRE to ML. Add ML-specific SLOs for model freshness and training pipeline reliability. And factor training costs into error budget math. One failure might cost $50K.
What's actually happening in 2025? What's the reality on the ground?
Chaos engineering market went from $4.9 billion in 2023 to a projected $32.75 billion by 2032. That's 23.5% annual growth. Google, Microsoft, AWS all released chaos engineering frameworks in 2024.
So investment in reliability tooling is exploding.
Right. 90% of organizations are planning significant cloud strategy changes. Hybrid cloud is critical for 48%. AI adoption is accelerating. And here's the shift. Execution challenges are overtaking adoption as the primary concern.
It's not should we do SRE anymore, it's how do we adapt SRE for our complexity.
Exactly. Here's your practical next step. This week, pick your top 3 services. For each, answer 3 questions. What's our availability target? What's our error budget? Who enforces it? If you can't answer all 3, you don't have SRE, you have hope.
That's brutal, but fair.
And here's the thing. The 26% adoption rate isn't a condemnation of SRE principles. It's evidence that implementation is hard. But the principles remain. Measure reliability, budget for failure, automate toil, learn from incidents. The implementation must evolve for 2025's complexity, but the philosophy is timeless.
So what's your take on the platform engineering versus SRE question we started with?
They're 2 sides of the same coin. Platform engineering builds the systems. SRE ensures they're reliable. The tension only exists when organizations force them to compete. When they collaborate, you get fast developer velocity and high reliability.
And both can use the same core principles: error budgets, embracing risk, blameless learning.
Right. Whether you're a platform team tracking deployment success rate or an SRE team tracking service availability, the error budget framework works. It aligns incentives. It turns politics into data.
Final thought. If you're in an organization where SRE hasn't stuck, don't assume the principles are wrong. Look at implementation. Are targets realistic? Is tracking automated? Do product managers understand error budgets? Is there executive sponsorship?
And remember, formal SLOs aren't the only path. Some organizations do reliability reviews without formal SLOs. Some use simple metrics. The goal isn't orthodoxy. It's reliable systems that enable fast iteration.
Pick 3 services, answer 3 questions, start this week.
Measure reliability, budget for failure, automate toil, learn from incidents. Those principles work in 2025 just like they did in 2016. The tools and techniques evolve, but the philosophy remains timeless.
That's it for this episode of the Platform Engineering Playbook podcast. Every topic, transcript, and summary you just heard lives out in the open at platform-engineering-playbook.com, where anyone can suggest updates or add insights through GitHub. If you've got thoughts, fixes, or new ideas, open a PR. And if you enjoyed the episode, rate us on your favorite podcast platform. We're always shooting for 5 stars. While you're there, give the project a star on GitHub. It helps others find and contribute to the Platform Engineering Playbook. This podcast is generated by AI, reviewed by AI, me and you, a community of engineers keeping our craft sharp. Thanks for listening, and see you next time inside the Platform Engineering Playbook.